Day 13 of 90, and today we fixed the bug that ships to production looking completely innocent. Picture this: your front-end component crashes because an API wrapper returned any, and someone on the backend renamed a field from user ID to account ID 3 weeks ago. TypeScript said nothing. Your editor autocomplete nothing. The error showed up at runtime, in front of a user. Generics are how you stop this from ever happening again, and by the end of these 5 minutes, you'll write functions that stay fully typed across every shape of data they touch. Here's the core problem. The moment a function needs to work with more than one type, most developers reach for any or cast with as. You write function fetchData, URL, string promise any, and that single any punches a hole straight through your type coverage. Now response.data.userid is any, response.data.anything you typed is any, and the compiler has stopped protecting you exactly where you need it most. A generic says, I don't know the type yet, but I'll remember whatever it turns out to be. That's the whole idea: a type variable, not a type hole. Let's build it. Define an envelope every backend response shares: interface API response T, data, T, status, number, request ID, string. That T is a placeholder the caller fills in. Now the fetcher, function fetch resource T, URL, string promise API response T. Watch what happens at the call site. You write const res equals await fetch resource user, /API/user. Suddenly res.data is a fully typed user. You get autocomplete on res.data.email, you get a red squiggle if you typo res.data.email. The type flowed from the call site, through the generic, all the way to the property access. No cast. No guessing. Compare that to the any version for 1 second, because the contrast is the lesson. With promise any, typing res.data.userid compiles fine, and so does res.data.usrid, and res.data.literally anything. Every one of those is a runtime bug waiting silently. The generic version makes the typo a compile error. Same code shape, totally different safety. And notice you wrote the function exactly once, but it works for user, product, order, anything. One function, fully typed, infinite shapes. That's generics turning TypeScript from a type annotator into a type reasoner. Now, sometimes you need to guarantee the generic actually has certain properties, and that's where constraints come in. Say you're building a data layer, class repository T extends, ID, string. That extends, ID, string, is a promise. It says T can be anything, as long as it has a string ID. Why does that matter? Because now inside the class, methods like findById, ID, string T, undefined, upsert, entity, T, and remove, ID, string, can all rely on entity.id existing. Without the constraint, the compiler wouldn't let you touch .id, it doesn't know T has one. The payoff is huge. Write const products equals new repository product, and every method returns a typed product for free. findById gives you product, undefined, fully autocomplete. And here's the part people miss: if you try new repository card item, and card item has no ID field, you get a compile error right at the instantiation site. Not buried in a method. Not at runtime. The mistake is caught the instant you make it, with a message pointing exactly at the missing ID. This is where it connects to real contract design. Remember our renamed field, user ID, becoming account ID? In a generic world, your user type is the single source of truth. The moment the backend schema changes and you update that type, every fetch resource user call, every repository user method, every component reading.userid lights up red across your entire codebase. The breaking change becomes a compile error you fix before deploy instead of a runtime crash a user finds for you. The compiler walks the whole call stack and enforces the contract. So here's your takeaway: generics aren't abstract library magic, they're how you stop lying to the compiler at your own API boundaries. Every any cast is a promise the compiler can no longer keep for you, a generic hands that promise back. Today, try refactoring one promise any fetch into fetch resource T, and add one extends constraint to a class that needs a guaranteed property. Day 13 done. You can now write code that stays typed across every shape of data and catches breaking changes before they ship. Subscribe for day 14, where we go deeper into key-off and map types.